Hey, welcome back. Here's a preview of what we want to set up for this video. By the end of this video, when we playtest, we want to print out whether or not we have won the game. So in the case where we lose a predefined number of apples, such as 3 for example, we currently have that hard-coded to 3 apples. Then we want to print false out to the screen in addition to the cleanup where we stop spawning apples, set the apple tree to stop redirecting and so forth. So far we've only really dealt with the lose condition, so the player has a sense of they can lose the game if they lose some of those apples. But in this section we also want to set up some win conditions. For example, if the player has scored a predefined number of apples, such as 10 for example, then we want to print out 2 to the screen, or less for debugging purposes, and we can actually set it up in a way to where we can specify that in blueprints. So if we have caught that predefined number of apples, then we want to print out 2 to the screen. However, when it is game over, so at the end of the game, it is important that we still handle that cleanup where we stop spawning apples and set the apple tree to stop redirecting. That is, whether we have won or lost the game, we want to still handle that cleanup at the end of the game. In upcoming videos, we want to set up a widget that displays whether or not we have won the game, maybe a countdown time as well, and this is a step in that direction. To begin, let's create a function that will handle the logic that we want to be executed when it is game over. Whether or not the player wins or loses, it is at the end of the game. So this is not to be confused with a losing only, so typically when you lose a game you get game over, right? If this is confusing, you may want to rename that function to handle game end instead, or something like that. This will take in a boolean b game1. We want to pass in whether or not the player has won the game at the end of the game. At some point in the program execution, which we will set up in this video, I will decorate that with the uFunction macro. Now before we provide any specifiers, I will navigate to the game modes implementation. Where do we lose the game? Well, when we have lost a number of apples, right? So in handle apple lost, currently hard-coded to 3. If we lose that many apples, then we lose the game, right? Remember, when we lose the game, we want to execute all of this code here. We want to stop spawning apples from any found tree, set the tree to stop redirecting, and also set that tree to stop moving. Finally, we also want to destroy the remaining apples. Now, if we think about it, it makes sense that we should execute this logic regardless of whether or not the player has won or lost the game. That is, it makes sense we should execute this logic at the end of the game when we handle game over, right? For an exercise, define the handle game over function, determine where to invoke that function, and determine the specifiers, that is for the uFunction macro. As a hint, remember that we want access to the boolean in blueprints, and use the result of that to display a you've won or you've lost widget to the user later. So we will actually invoke the handle game over function in blueprints. We are not going to implement the handle game over function in blueprints. We want to move all of this code where we stop spawning apples, stop redirecting and so forth into the handle game over function, and then simply call handle game over when apples lost is greater than 3. For this reason, we will specify blueprint native event in the uFunction macro. I will create the definition of the function. And actually I will move that down. Remember, we must add that underscore implementation following our function identifier. Now I will cut this code out from the handle apple lost function, including this where we disable input on the player controller, and paste that into the handle game over implementation. Fix that indentation. Shift tab should work fine in this case. Next, back in the handle apple lost function, if we lose 3 apples, then we lose the game, right? So we invoke handle game over. Remember that this function takes in a boolean whether or not at this point in the program execution the player has won the game. So we pass in false since we have lost the game at this point. Currently we have the max amount of apples that we can lose in the game hard-coded to 3. At this point we know how many apples we can lose before we lose the game. So we should probably set up some win conditions too, right? We cannot just lose the game. So back in the interface for our game mode, let's declare a variable for the amount of apples that the player should catch in order for them to win the game. I will call my variable apples to catch. For debugging purposes, you may want to make this a small value such as 3. You may be tempted to make that something like 3 for example, but remember we actually use that blueprint derived game mode. So I won't assign a small value to this. I'll think about a more reasonable or proportionate value compared to the losing condition. Let's say since it's the first level, that the player only needs to collect 10 apples in order to win. Since we are here, we can also declare a variable for the number of apples that we can lose in order to lose the game. This is tied to our petals, so the number of petals that we have. So we could hardcode that value as we have done up until this point. But I will declare this variable apples to lose for readability in the implementation. Now, instead of searching for that hard-coded value in the source file, the programmer will more easily find that value, that variable in the header. That is if they want to make a change or see what that is. We also have to keep in mind that the game design typically changes slightly over time. I will set that to 3. So now we can decorate those properties with the uProperty macro, and then provide the appropriate specifiers, edit anywhere, and then the category to setup, for example. Now we can replace the hard-coded literal with our variable. If apples lost is greater than or equal to apples to lose, then we handle game over and we lose the game. Next, where in program execution do we win the game? Well, in the handle apple caught, right? If apples caught is greater than or equal to the number of apples to catch, you could actually also name those variables apples to win and apples to lose if you want, something like that. We call handle game over again, this time passing in true. We win the game here. How easy was that, right? With the setup, at the end of the game, whether we win or lose, the handle game over implementation will stop spawning apples, stop redirecting, set should move to false, that is for found trees, and it will destroy the remaining apples. Let's build a run to see what happens. I will open up the game mode blueprint, and in the graph we can search for handle game over. I will select to add that event to the graph. This will give us that boolean that we can use. That is at the end of the game, whether or not we have won or lost the game. I will drop down a print string node. Change the duration to 10 seconds. Drag off from the one game boolean and hook that into the in string. Of course, that will give us this conversion node to convert from a boolean into a string. Compile and save, and let's test this out. I will start by testing the lose condition, and notice something strange happens. We keep losing apples. The apple tree does not stop moving and it does not stop spawning apples. Also, false keeps printing to the screen. Why do you think this is? For an exercise, attempt to fix this issue by yourself before moving on. Okay, welcome back. Before we continue, let's set the win condition to a lower value for debugging purposes. Under class defaults in the setup category, we have apples to catch. Again, you may want to name that variable apples to win if you want. I will change that to 3, compile and save. And if we playtest now and attempt to win, we can actually keep catching apples. It's like we cannot win and will eventually lose when we go to get a coffee or something. The game does not clean up as it did before. Since we are executing the handle game over event in blueprints, the parent version of the function does not get executed. That implementation version does not get executed. What parent version is that? Well, remember this blueprint class derives from our C++ Apple Picker game mode. So to fix this issue, we need to invoke the parent version. How do we do that in blueprints? Well, if you recall, we can right-click on the node and select Add Call to Parent Function. Hook that up, compile and save. And if we playtest now, I'll attempt to win again. Let's see if our apples to catch value works. The value that we set in blueprints. I catch 3 apples and we get a true printed to the screen. The tree stops moving, stops spawning apples, and I cannot move the basket at this point. So the cleanup was executed and all of that cleanup is handled on the C++ side. And we don't have to create a huge mesh of nodes in the blueprint graph to get that functionality. This again is another example of the usefulness of having the C++ backend and then having the ability to expose certain functions and events to blueprints. Let's test the lose condition. So if we play again and lose this time, we get the false printed and the same cleanup step happens as before. Back in the game mode blueprint, the reason why we have the setup is that once we have a widget set up which will display text to the player, not just these debug printouts that we have, but some proper text, we can hook up the functionality that we want for that after this parent handle game overcall. To clear up the printout a bit, we can do an append. We can append some strings such as game1. We can append that and the result of this boolean, so whether that is true or false. And of course in that case we want the string such as game1 first here, so I will plug in the result of that conversion to a string. I will plug into B, and then for A I will type in the string literal game1. We append whatever goes into B into that, which of course will be true or false, and then we're going to print the resulting string out. Playtest that, and that just makes it a bit easier to see what is going on, to understand what is going on. Remember that on the print string node we have this option to print to the log. That is checked by default, so I'll just make sure that that is checked. Then in the output log I will make sure that we have show all for the category, so all of those categories will show up. Then if I play, by the time it is game over, we get this game1 false. So we get the same printout. We get the same printout in the output log. Now we can see what the filter is for that. So that is log blueprint user messages. So we can filter for that. Instead of having all of the categories show up, we can filter for that, so that only that category and the log temp category will show up, for example.